Good morning, dear students. My name is Ferhan Mazher, and today is 15th of March 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. Today, we have set our hearts to solve alternative to practical ATP paper. We call it paper 4. And today we have selected a paper of May-June 2017 4-2 paper. This ATP paper belongs from the zone 2, or you can say this belongs from the variant 2. The time allowed for this paper is 1 hour. So let's start this paper. So May-June 2017, 4-2 paper, 1 hour is allowed, paper 4 we call it. So the first question is coming up on your screen. A student measures the acceleration of free fall g. He drops a metal ball from a height of 1.000 meter onto the floor and measures the time t it takes to hit the floor. Figure 1.1 shows the ball and a meter rule held vertically in a clamp. So here we have a vertical clamp. Here is that metal ball. We have dropped the metal ball from here. It has dropped to the ground. On the figure 1.1, draw the position of the ball at its point of release. So we have to draw the ball here from where you release the ball. So what you will do, you will draw here a horizontal line, a dotted horizontal line, and then draw a ball. And the bottom of the ball should be on that dotted line. So let me show you. So you can see on your screen that I have drawn that ball at the height of 1 meter from the ground. Here, this is the ball. So this is what they were asking. Okay, so the next part is, he says, he repeats the experiment and obtains the following 5 values of t, measured in seconds. 0.65 seconds, 0.60 second, 0.68 second, 0.59 second, 0.61 second. Calculate t average, the average value for t. Give your answer to 2 decimal places. So if you want to find the t average, the method is very simple. You add these 5 values, and whatever the sum you get, you divide it with 5. So you will get the t average value. So let me show you. So here we go. So 0.65 plus 0.60 plus 0.68 plus 0.59 plus 0.61 equals to, divided by 5 equals to, so you get 0.63 seconds. So you get 0.63 seconds. Okay. So then they say, suggest why the value for t average is not given to more than 2 decimal places. So we don't give the t average value. We keep the t average value to 2 decimal places. The reason is, look at your data. The raw values which are given in your data, they all are in the 2 decimal places. So your average value should also be in 2 decimal places. So the answer which we have written for this question is, raw data, each measurement is in 2 decimal places. So that's the reason that why we have taken. Okay, so the C part is the acceleration due to the free fall. G is given by the equation. G equals to 2h divided by t average square. So where h is 1.000 meter, calculate the value for the g. You just have to put these values here. So I know the 2, I know the h value, I know the t average value. We just calculated that. And we just have to put these values here and in this formula and just do the calculation. So let me show you how this is done. Okay, so 2 multiply 1 divided by 0.63 square equals 2, and that will be 5.04. So the G value will be 5.04. So, okay, so then they say, another student suggests that to obtain a better value for G, the ball should be dropped from a height greater than 1 meter. Explain why this student is correct. So, you see, when you drop the ball from more than 1 meter height, the time taken for the drop will be larger. So when the time taken will be larger, so the measurement will have less effect of the human reaction time, because the time will you are measuring will be larger, so your reaction time will be a smaller portion of the time measured. So that's the reason. Let me read you my answer, and then we will have a look at the marking scheme. Ball will take longer time to drop. This reduces the effect of human reaction time on the time measurement of the ball drop. The the human reaction time will be a smaller portion of the time measured. So let me show you. Let me check one if this question is completed. Okay, so the question is completed. So let's have a look at the marking scheme. So my dear students, the marking scheme is showing up on your screen. Okay, so we have to use the size. Okay. So longer time, sufficient time to fall, reduce percentage error in the time, reduce the effect of human reaction error. Okay, so our answers are right. I have already checked my answers with the marking scheme. You can pause the video and you can take your time to read this marking scheme. Pause the video and take your time. Okay, a student A student investigates a series circuit containing two non-identical lamps P and Q. Both lamps need a working voltage of 2.5 volt to be at full brightness. She sets up the circuit shown in the figure 2.1. The student adds a voltmeter to the circuit to measure the potential difference across the lamp P. So A part, first portion is on the figure 2.1, draw the symbol for a voltmeter to show where it is connected. So we have to add a voltmeter which can measure the voltage drop across the lamp P. So parallel to the lamp P, here I will add a voltmeter. Let me show you. So you can see on this your screen that I have added a voltmeter with the correct symbol parallel to the lamp P. So this voltmeter will be able to measure the voltage drop across the lamp P. Okay, so the next part is, he says, figure 2.2 shows the reading on the voltmeter. State the voltmeter reading VP shown on the figure 2.2. So this reading here is, this is 2, this is 3. So this is probably 2.1, 2.2, 2.3, 2.4, 2.5. So this is 2.4 volt, 2.4 volt. 2.4 volt. So I hope you understand this. Okay, so let's move to the next part. He says 2.4 volts. So I will write here 2.4 volts. She measures the potential difference across the lamp Q and records the value in the figure 2.3 together with the brightness of the lamp. So the the voltage drop across the P is 2.4 volt. It will be bright, and the voltage which the Q is getting is 0.6 volts. So it will not let. Okay, so simply you have to add that reading. Let me show you. I have added that. So this is how you will add that value 2.4 volt in that table. Figure 2.4 shows the reading on the ammeter. So here we go. The reading on the ammeter is showing. State the ammeter reading. So this is 0.0, sorry, 0.1, 0.2, 0.3. and this is 0.4. So this is 0.32, 0.34. So the pointer is at 0.31. So the reading is 0.31. Let me show you. The reading is 0.31 ampere. Okay. The student states that because lamp Q is not lit, its filament is broken. Explain how results show that this statement is incorrect. The filament of the lamp Q is not broken because you see in the circuit, the current is flowing and P and Q, they are connected in series with each other. So if the lamp filament has broken, the current will not flow because the current is flowing, the ammeter is showing some reading, and the lamp P is also lit. So that shows that the current is flowing in the circuit. So the statement is wrong. The statement is incorrect because the P is lit and the current is flowing in the circuit. So let me show you. Current is flowing through circuit and the lamp P is lit. So the Q is not correct. It's incorrect. So hopefully you understand. Okay. So just one reason why the lamp Q does not glow. You see, the voltage you provided to the Q is not lit. Q is not getting enough voltage to lit. That's my answer. Okay, so now the question number 3 is coming up. Okay, so we will have a look at the marking scheme. So my dear students, the marking scheme of the question number 2 is showing up on your screen. You can pause the video and you can take your time and read this marking scheme carefully. Compare the answers which I gave to you with this marking scheme and try to write your own answers and compare them, check them by reading, by comparing them with this marking scheme. So pause the video, take your time. A student investigates the effect of 3 different insulating materials on cooling of hot water in a beaker. The following apparatus is available: thermometer, stopwatch, 250 cubic centimeter glass beaker, 250 cubic centimeter measuring cylinder, cardboard, cotton wool, cloth, boss clamp, and stand. A supply of hot water is also available. Write a plan for the experiment. You should you should explain how to carry out the experiment. A diagram is not required, but you may draw one if it helps to explain your plan. So let me show you the question. Okay, so it's a 2-mark question. So let me show you. So we have to plan an experiment where we can check that insulating materials, what the effect they have on the cooling. So let me show you my answer. So here you can see on your screen, I have drawn a diagram where we have shown a beaker which is filled with hot water, and we have inserted a thermometer to check what's the reading of the temperature, and we have also placed a stopwatch with it, so we can measure that how much time for cooling you have given. The lagging is done with the insulating material, and we will note down the initial temperature, then we start the stopwatch, we will give it 10 minutes, and then we will note down what is the final temperature, and then we will calculate how much is the temperature drop in 10 minutes. So then we will repeat this experiment with the other insulating materials. So let me read my answer. Wrap cotton wool around beaker. Pour hot water into beaker. Note initial temperature of hot water and start the stopwatch. After 10 minutes, note the final temperature. Calculate the temperature drop. Repeat the same experiment with a different material wrapped around the beaker. I hope you understand this. Okay, so then we have the B part. It says state any quantities that need to be kept constant. Usually when you do this experiment, the few things which should be kept constant is for all the experiments that the room temperature in which you perform the experiment for all the experiments should be same. The initial temperature of the water should be same. The volume of the hot water in the beakers should be same, and the conditions of the room should be same. Amount of hot water, time allowed for the cooling, room temperature, if possible, initial temperature of the hot water should be same. Okay, so let's move to the next part. It says draw a table with the headings to show how to display the results. Okay, so we can have a, for example, material, initial temperature, final temperature, and change in temperature. And this is for after we give 10 minutes of the cooling. So here I have tried to draw a table in which I'm showing that what should be the headings, materials around the beaker, initial temperature, final temperature, and drop in the temperature. So for different materials, I will do these things. And we have supposed that we will give 10 minutes for cooling. Hopefully you understand. It says explain how the reading can be used to reach a conclusion. You see, we will take the initial temperature of the water, same in all the experiments, and we'll pour the hot water into different materials, and we will check that after 10 minutes how much is the voltage, how much is the temperature drop. So the one in which the temperature drop will be the will be the least. That will be the best insulator. That will be the best insulator, I think. So let me in equal intervals of time compare the temperature drop for each insulating material wrapped around the beaker. Smallest temperature drop means the best insulator. Okay, so that's my answer. And then we reach the question number 4. But before going to the question number 4, let's have a look at the marking scheme. So my dear students, the marking scheme is showing up on your screen. So you can pause the video and you can take your time, read this marking, each mark and each description, read it carefully, check my answers, your teacher's answers with this marking scheme. It's a very important habit. Okay, so let's move to the next question. The question number 4 is showing up on your screen. He says, an object is moved between a lamp and a screen. A student investigates how the height of the shadow cast by the object on the screen changes. The apparatus is shown in the figure 4.1. So here you have a lamp, here you have an object, and its shadow will be formed on the screen. The distance between the screen and the lamp is 80 centimeter and is represented with the capital D. The distance between the object whose shadow is formed on the screen and the lamp is represented with the small d. So this is the diagram. I hope you understand this diagram. Let me show you, make it bigger so that it makes more sense to you. Okay. He says that the object is a square sheet of white card. The length of each side is H, capital H. The height, the object is attached to a pin and supported by a cork as shown in the figure. Okay, so this is that object whose shadow is formed, and this is the height, and it's in shape of a square. So he says measure and record the length H as shown in the figure 4.1. So with the help of the scale, measure how much is this. I have measured it. It is 2 centimeter. So let me show you my answer. So I have measured that capital H is 2 centimeter. So we are going to the next part. He says the screen is placed at a distance capital D equals to 80 centimeter from the center of the lamp. She places the object at a distance d equals to 70 centimeter from the center of the lamp and observes the shadow made by the object on the screen. The shadow is shown in the figure 4.3. So this is the shadow. It says measure and record the length h of the shadow shown in the figure 4.3. So I will measure this height of the shadow, and that will be 2.3 centimeter. I have already measured it. So you can see I have written there 2.3 centimeters. So then it says, suggest why it would be difficult to measure accurately the length of the shadow. You see, this length of the shadow, we cannot measure very accurately. The reason is that the edges are curved. The edges are curved. The shadow's edges are curved, so it's difficult to measure it. So let me read my answer. Edges of the shadow are curved. Okay. So then let's move to the next part. He says she repeats the procedure for the value of D of 60.0 centimeter, 50, 55.0 centimeter, 45.0 centimeter, 30.0 centimeter, and 25.0 centimeter. Her results are recorded in the table 4.4. So add your value of the age from the B first part to the table in the figure 4.4. So the value which we just calculated, this value, 2.3, they want us to add this to the table. So we will add it like this, 2.3 centimeter. Okay, so then what they say, let's have a look at the path. He says on the figure 4.5, plot a graph of 8 centimeter on the y-axis against d centimeter on the x-axis. Start both axes from the origin, draw the smooth curve of the best fit. And this is that table, that exercise. This is that grid basically, and we have to draw on this grid. So you can see this grid here and this grid here. So we have to draw. So let me show you. So this is your x value, this is your y values, x values and y values, and here you can see I have tried to plot it. So 10, 20, 30, 40, 50, 60, 70, 80, d, small d in centimeters, and the h is here 10, 1, 2, 3, 4, 5, 6, 7. And then I will plot this table at 72.3, at 62.7, at 55 and 2.9, and at 45 3.6, at 45 3.6, and at 55 2.9, and then at 4.5 3.6, at 4.5 3.6, and at 30 5.3, at 30 we will have 5.3, at 30 we will have 5.3, and at 25 you will have 6.4. So then I will join these points, these dots, with the line of best curve, with the best curve. Okay, so we are done with that. Then their question is, use your graph to find the age 40, the value of the age when the object is 40 centimeter from the center of the lamp. So the D value is 40, so we have to find the H value. When the D value is 40, we have to check how much is the value of the H. It's 40 something. It's 40 something, okay? So let me show you. Sorry, I said 40, it was 4.1. So use your graph to find the age 40, the value of age when the object is 40 centimeters from the center of the lamp, and from that graph I can tell it's 4.1 centimeter. The student suggests that the value of the age 40 is related to the length capital H of the object by the equation. So age 40 is equals to 2 times capital H. So calculate the length of the capital H of the object using this equation. So 4.1 is equals to 2 capital H. So capital H will be 4.1 divided by 2, and that will be 2.05. So approximately H is 2. Compare the value of the value for H calculated in the D second part with the value that you measured in the A part. So state whether your results support the student's suggestion and justify your answer reference to the results. So it's 2, that value was also 2. That value was 2. Okay. So it means the values agree with each other. So it means that yes, and the results are very, very close. So then we have this third part. He says we're done with that. Then E part, he says extend your graph to predict the length H20 of the shadow when D is 20 centimeter. So when the D is 20 centimeter, we can find out. So when the D is 20, from here I will go to the graph and I will check what's the reading. Is 7 point something. It is 7 point something. It is 7.2. Then he says the students suggest that the distance D should be less than 10 centimeter. Give one reason why this is a sensible suggestion. You see, if you make the D like equals to 10 or more than 10, the shadow will become very large, more than your screen. So D was kept constant throughout the investigation. Suggest why. Changing D will change the height of shadow. Comparison will be no more fair. Okay. So if you change the D value, so it will, the shadow will becomes larger. So our paper is over. So first of all, let's have a look at the marking scheme of the question number 10. Sorry, question number 4. So the marking scheme of the question number 4 is showing up on your screen. So my dear students, you can pause the video and you can take your time. You can read this marking scheme. I have already compared my answers with this marking scheme. But for you, it is very important that whenever you solve a physics question or physics paper, always check its answer, compare its answer with the marking scheme. Hopefully, you will follow my instruction. So, my dear students, today we have done May, June 2017 for a 2 paper. It's an alternative to practical paper. We call it ATP. We also call it paper 4. I hope that this video will help you in solving the past papers and preparing for the upcoming Cambridge exams. If you think that these videos are helpful to you and they can be helpful to your juniors and seniors, do share the link of this video with your class fellows and other students who are in O levels. And because when you will share the link of this video onto your Facebook and onto your Instagram and onto your Twitter accounts, that will help me to promote my channel. So it's a great blessing for me to be able to be helpful online to you. So thank you very much, everyone. Have a good day. God